Let's take a look at the agenda for this semester. So we have about 15, 16 weeks that we're going to be together, and they're going to be roughly split into the following topics. Right? So this week it'll be mostly an introduction to what the course is all about, what software engineering is all about. We'll talk about some of the impetus for applying software engineering to these very, very hard problems. Why do projects fail? Some of the solutions that historically have been proposed, and what is the current standard in managing projects today, large projects. We'll go through the software development lifecycle, the original waterfall methodologies of managing projects, and today most folks use Agile, right? But it's not the end, right? These processes have been evolving throughout history for the last couple of decades, right? And they'll continue to evolve, right? So it's not the end solution. Hopefully you folks will come up with other solutions, right? More innovative ways of organizing large teams. So this week we'll be mostly talking about introducing the course. We'll talk about the software methodologies, architectures of what we're going to be building this semester, and setting up the environment. So on Friday, when we come back on Friday, we'll talk about how to set up the environment. We'll set up a remote server. We'll deploy a Hello World web application. Right? We'll introduce some really, really simple stuff and get you going with the assignment. Right? Hopefully by the end of the week, you'll have the assignment already done. Right? And then on Tuesday, you'll submit it as completed. So the first assignment is going out today, and it's due next Tuesday. But I know it's going to be a very painful week, right? Setting up environments is painful, right? The right versions don't match with these other versions. You're missing a plugin. It's the wrong dependencies. It's a pain. I know it's going to be a pain this week. Right? So the Tuesday due date is going to be a soft due date. If you're not done on Tuesday, that's fine. Right? We're not going to penalize you. We understand that it's going to be painful this week. Right? And the TAs and myself will try to help you get through this painful week. Right? And try to handhold you as much as we can. Right? So please, if you run into problems, ask on Piazza. Be as much as specific as you can on Piazza so we can help you out. And hopefully we'll write it out successfully by next Tuesday. Next week, we'll start talking about requirements. One of the things that we're going to introduce today is that one of the hardest part of any software project is agreeing on what is it that we're building. It seems silly, but it's very hard to agree, especially on large teams, on if we do all understand what is it that we're building. Okay, everybody will have different understanding of different pieces of what it is that we need to build, but nobody will have an overall arching understanding of what it is that we're building, right? Or anybody could possibly understand all the dependencies about all the different pieces. Okay, so that's one of the hardest parts to do is agreeing on the requirements, how to document it, what's the right level of details that I should document this, right? In waterfalls, we'll see, they focus a lot on documentation, on trying to get it right the first time, right? And identifying, and not until we were comfortable on agreeing on what it is that we were building would we actually start building it, right? So folks were very reluctant on signing off on something that we were building if I don't understand what it is that we're building, right? We saw that actually it made sense at a particular time in history, but as we've progressed, we saw that we've bitten the bullet, and it says, okay, there's no way I'm going to understand all this, right? We'll have a general sense of what it is that we're going to build, but we're going to leave the details as we go on, right? And that's more of the mantra of using Agile methodologies today, that as you progress and you understand more the domain, problem domain, right? then you're at a better place to actually document what it is that you're specifically building. Okay. So we'll talk about requirements. It's a new skill. From now on, every single assignment after this requirements assignment, you'll be required to do some requirements analysis for all the assignments coming after this, okay? Which is very common. Right? In every sprint, we'll talk about sprints. There's a portion where the first part is understanding what the requirements are, documenting enough so that we all understand what it is that we're building, making some design, and then go off and build it. Yes? So every single assignment, the third, the fourth, the fifth, and so on and so forth, will ask you to do some requirements in all of them. Even if it's not explicitly, you'll be expected to do some requirements analysis and documentation with all the subsequent assignments. Assignment number, in requirements, we'll talk about how to document it. We'll introduce use case analysis. We'll identify who the actors are, the domain objects. We'll create use case diagrams. We'll document several use cases on who the actors as they interact with the system, right? What the exception cases are, how to handle them, and there'll also be and also in every single assignment you'll be asked to implement something, right? That is related to that particular assignment. So there'll be a theoretical portion of it, but also some hands-on, build something, right? Week number 3, we'll talk about planning. That's another part of software engineering. Okay, we know we have to build all this stuff, okay, but we don't have infinite time. We don't have infinite resources. So we need to prioritize, right? There's a limited time. There's a limited amount of money. With what we have, what can we build, right? What can we prioritize and say, well, let's focus on this first and then focus on that later. So somebody has to agree on what should be built first or not. And that's part of the planning. Planning is trying to do the best with what you got, right? We don't have all the time in the world. We don't have all the knowledge or skills or software or developers that we could possibly want. So we have to prioritize. We have to say, let's do this first, and then this, and then that, right? So there's also some skills in that. So we'll talk about how to plan, how to come up with stories, and how to estimate how long they might take, and we'll introduce the Jira as the kind of the industry standard on how to document all these tasks. Right? We'll say, okay, well, we'll create a project, we'll create a team. These are the members of the team. We'll start creating all sorts of things that need to be done. It's a glorified to-do list. Jira is a glorified to-do list. Okay. These are all the things that need to be done, right? And now we're going to start feeding all the things in a particular sequence of what gets done first, and we'll keep track of all the status of each one of the things that need to be done, all the tasks. Who's assigned? Who has this particular task assigned? Have they started on it? How long have they been working on this? Is it done? Is it deployed? Is it in QA? Has it been tested? It was deployed, but there's bugs in it, so it has to go back to development. It has to be to be worked on again, right? So we'll introduce Jira and how to create teams, boards, issues, and how to groom backlogs and create sprints to then do the sprint that particular week. We're going to be running 1-week sprints. I don't like 1-week sprints, but it's a short semester. We only have 4 months. Typically, I would prefer maybe 2-week sprints, maybe even 3. I think 3 is a little bit too long. 1 is too short. But it's academia, and we only have so many weeks in the semester. So we're going to run 1-week sprints. Okay. So every week you will be, after we know how to plan, all assignments after that are going to require you to do some planning. Okay, you went through the use cases, so well, you're gonna have to do some planning. That these UML class diagrams need to be built, these use cases need to be created. I need to read up on this. I need to do that and the other. Okay, so there is nothing that you should be doing that is not on Jira. Right? If you're doing something and it's not on Jira, you're doing something wrong. Right? Everything should be, there should be a task for everything that you do. Right? Every time, every single moment should be documented on what have you been doing. All right? So planning. Week number 4, we'll do some design, meaning, okay, we've identified these actors, we've identified these domain objects, these use cases. We need to design. We need some data models. We need classes. We need sequence diagrams. We need one-to-many relationships and many-to-many. We need a table where to store all this, right? So we'll need to create a relational data model for this, right? So we'll spend some time designing, right? And we'll implement some Java classes and some relational database tables, right? We'll map the Java data model to a relational database. We'll expose them as a web service, right? And we'll do some JSON work here. Right? So we'll introduce REST, JPA, UML, class diagram, and relational models here in design. Also in design, we'll do some design on the front end. Right? We'll do some design on the front end. Some of you might have done HCI. Anybody done HCI? Human computer? All right. So some of this will be boring to those who have done HCI. We'll go over some of the best practices and user-computer interaction. We'll do some design, some wireframes. Some flows. We'll think on how is it that we'll try to map the information onto some set of pages or screens that need to flow in a particular fashion. We'll create some prototypes. We'll do some horizontal prototyping, and so that's on Tuesday. On Friday, we'll actually try to build some of these pages. Right? All throughout, you might have been asked to create a couple of wireframes, where you might have been asked to create maybe some simple HTML just to introduce you. I'm not assuming that you know HTML. I'm guessing that most of you do. But we'll give you as much HTML already done so that you don't have to work from write stuff from scratch. Okay, so that when we get to this week in user experience, we'll do some front end development. Right? We'll do a crash course on React. Only the absolute minimum that you need. If you feel that you're much more comfortable and confident of using some of the more advanced techniques, go ahead, right? If you know Redux, or if you're familiar with some of the navigation and state management and whatnot, go ahead. It's not required, right? But if you feel confident doing that because you've done it in some other courses or at work or whatever, it's not required, but it's welcome. Okay. All right, so the week after that, week number 6, we'll introduce testing. Where you'll be asked to make sure that whatever it is that you're building, you might make sure that if it worked at some point, that it will keep working from now on. Right? Up to this point, you might have been doing some testing manually. You might have worked at something and it doesn't work, and you fix it over, and you're evaluating as you run it and test your hypotheses. And as you run it, it says, okay, it's not behaving exactly, yes. And then once you got the algorithm right, you says, ooh, I'm going to leave it there. Okay. So testing is the engineering part where you want to make sure that you identify what are the boundaries of that algorithm, that it should behave always as expected. And want to make sure that if it worked at some point, that you never break it again, right? Inadvertently, right? Perhaps as you're fixing some bug, you're introducing other bugs. So you want to make sure that you automate some of the testing so that if it worked once, it will always work from now on. And that you can identify that if you broke something, the test will tell you something that used to work is no longer working. So testing will focus on 2 aspects. First is the functional testing. Is it doing what I'm expecting it to do? Is it behaving correctly? Right? Is it transforming this data model into this other data model? Right? So that's functional testing. And for that, we'll introduce JUnit for the Java portion. But also we'll talk about structural testing. As in your source code, you might have had tons of if statements all over the place and lots of loops all over the place, yes? And your algorithm might be some complex set of branches and decisions. And you want to make sure that whatever tests you generate, you make sure that all your branches are being tested, right? There might be certain branches that your source code, it's so rare that the conditions are such that you actually traverse that particular branch. So that code might go untested, and might go into production, it never having been tested. Yes? So you want to make sure that you create your test in such a way that every single path of your algorithms have been tested, right? So that your inputs to your test, your inputs to your algorithm, make sure that all the lines in your source code have been at least once traversed through them. Okay, so structural testing measures the code coverage. How much of your code has actually been tested. We'll expect at least an 80% coverage at first. Right? Make sure that your tests cover at least 80% of all the source code. But we're going to ratchet that up every sprint after that. Right? So the next sprint we'll expect 82. And the following sprint 84. Right? Well, at least to bring it up to 90 by the end of the semester. Right? So we'll expect by the end of the semester 90% code coverage in all your source code. Make sense? Now this is source code in the middle tier, right? In the Java, right? In your JUnit. The following week we'll do some client testing, some client-side testing, right? Where you want to make sure that not only the source code in your Java or PHP or Python or your server is being tested, but also your source code that runs on the browser, your JavaScript is being tested. In this case would be your React is being tested. More and more applications are bringing some of at least the presentation logic is becoming more and more complex on the front end. So that logic needs to be tested. Is it working? If I click here, does this actually show or hide? Right? Or if I click on this, does the actual table populate? Right? Does it actually go and fetch data from the server and then populate the content? We want to test that. So we'll do unit testing on the client side, and for that we'll be using Jest. Jest is useful for testing React applications. Okay, all right. Notice that every single assignment has added an additional engineering skill, right? And every single assignment will expect that, even in this assignment, you'll be expected to also provide structural testing, right? And also provide functional testing, right, for this assignment. Right? It's a very common, it's a new skill, right, but needs to be applied every single sprint as you go forward, right? Obviously, what we might need to do is make the actual thing that you're building simple enough that you could complete it in an actual week, in an actual sprint. But we'll see. That's the 8th week. On the 8th week, we'll have the midterm. We'll have the midterm right before we go out to spring break. All right? All right, we have spring break. When we come back, we'll introduce continuous integration. So up to this point, all that you've been doing here, creating your application, coding, running your tests, building, compiling, packaging, deploying to the server. You have been doing this all manually, right? You've been doing this all manually. And anything that you do manually, right, is error prone. Right? We make sure that the process of building things, testing, packaging, deploying, you want to automate as much as possible. All right? So continuous integration is the concept of automating all this so that you can just focus on your source code. Just focus on your source code. You don't have to, and you create your tests, but you don't have to now manually every single time run your tests and package and deploy and whatnot, right? You want to automate this, and every time you check in something, and when somebody proposes a PR and is going to go out to QA, right? The system automatically, runs your tests, right? And if they're successful, right, it packages, it deploys, right, and restarts the server for you. But if something went wrong, if your test failed, right, it should notify you. Hey, it failed. I'm going to reject your code proposal, right? Because it's going to break the system. Right? The system should never allow any bad source code to make it into the master branch, right, and be deployed into an environment, right? So continuous integration will focus on automating all this, so that you don't have to do this manually. For that, we'll use Jenkins as one of the industry standards on automating these build processes. Okay. Then with the week after that, we'll do some quality assurance testing. These are the folks that take the requirements, right, the use cases, and test the application, right? They manually click and drag and try to break the application to see if it meets or it doesn't meet certain requirements, the use cases that you documented earlier, right? They'll create test plans. And if you click here and you log in here and you do this, that, and the other, right? Whether it passes or not the use case. Yes. So we'll talk about quality assurance, and then we'll talk about automating the quality assurance, right? Instead of having a human being, actually going through the click, we'll automate this by using tools such as Selenium. Selenium allows you to record the clicks and the drags and the keyboard strokes, right, that a tester would do, right, so that all this testing can also be automated, right? Whenever you add a new page or you make a change to a user interface or add a new field or a new button, right, you want to make sure that that button is actually tested, right, that it behaves the way it's supposed to behave, and you want to automate that as well. So we'll talk about how to automate all that. Next, we'll do some integration testing. This is getting towards the end. Folks have been creating their web services, they've been creating their data models, and they're somewhat disparate from each other, perhaps. It's time to start thinking of how to bring that together, how to integrate, start working with, how do I integrate the feature that was worked on this team with features that were worked on this other team, right? How to integrate these things, right? So integration testing will allow us to create tests that take into account the entire stack, right? As opposed to testing individual pieces, right, into individual unit tests, right? We want to test, all throughout the stack. If I click on this button, is this record actually removed, right? So I'm testing, the UI all the way through the middle tier, all the way through the data model, all the way down to the database. Okay, so we'll talk about how to integrate, how to test that. Then the last couple weeks. Will be focused on focusing on the project. Just build for the next 3 weeks is meeting here, breaking out into teams, and the TAs and myself having and helping you integrate or any problems you might have in the build process, and helping you out bring it across the line. Right, so those last 2 weeks will be focused on finishing up the project. The last day of class is Tuesday, April 16, I believe, if I read that right. That will be our final exam. Right, it will be very similar to the midterm. Right, lots of multiple choice, lots of fill in the blanks, a lot of giving a UML class diagram. We'll ask you things about it. We'll give you also some long paragraphs and ask you about functional requirements, non-functional requirements, right? So typically you'll have a grade right away. So a week after that, the project is due. The week after that, it's on April the 22nd. That week, the TAs and myself are going to be very, very busy. We will not be available for answering questions. We'll be grading, trying to finish all the grading that last week, since grades are due a week after that, right? And the grades are due on the 29th. So you'll have your grades will be available on the 30th. Will be on MyNEU. All right. All right. So that's pretty much the agenda that I'm thinking of following throughout the semester. Any questions? Proposals? You think something is missing, or yes?
So for each assignment, within our teams, are we going to break up and do individual tasks within that, or does everyone do like the same thing and then we kind of like talk about it?
So each assignment will have 3 portions, right? It'll ask you to do something individual. We'll ask you to do something within your team, and we'll ask you to do something within the organization. Right, so every assignment will ask you, these kinds of steps, right? And you'll be graded individually, as a team, and as an organization. Okay.
So the first assignments.
The first 2 are individually only. Yes. Yeah. Also, yes.
Just something off topic. I don't see any like reading materials on there. Does it mean we won't be doing much?
Yeah, it'll provide it as part of the slides will be there, and also in Blackboard. Yep. Also, each assignment will introduce you to a technology skill. So, for instance, this first assignment asks you to do a very simple Java object class. Right. For those that have not done Java, which I don't think is everybody. How's our Java? Okay, so all right, good. And it'll ask you to create also a simple Spring Boot server. Anybody done Spring Boot? A couple here. Right, half the class maybe has done Spring Boot, which is good. So we'll walk you through creating a very simple Spring Boot application, and create a simple RESTful a REST service that returns a hello world. Right, so that'll be a skill, a particular skill, which you're not going to be graded on, right? Because that's a particular programming skill, right? So we're going to give you that. We'll give you that, and each week we'll give you another skill, right, which will be useful as you go further, to build the application. Okay, so those skills you won't be graded on. We'll give you that. Right? You'll be graded on the engineering portion of it, on how is it that you learn about that, or create tests once you know how to create tests. Right? So that portions you'll be asked to be proficient on.